Let's solve for the integration by substitution of this problem here. Integral of 6x times square root of 3x squared plus 1 dx, right? So the first thing when you see such a problem is you want to know if it agrees with this kind of format, which is integral of u prime times u dx, all right? Hi, everyone. I'm Professor Kujo Kamlavi from the platform Prof. Kamlavi Math for Fun. Please subscribe to our social media platforms on YouTube, TikTok, Instagram, and Facebook. We have so many videos there for you so that we are continuing to grow, and we need you to grow. So let's see you there. Thank you. All right? So let's go back to this problem. So what we're going to have to do first is to set up one of these two functions between the 6x and the 3x squared plus 1 equals to u. Because if you look at it, you can already tell that the derivative of this one is 6x. The derivative of 3x squared is 6x, right? So that means we're going to set up u equals to 3x squared plus 1. As you guys can see, we do not need to take the radical with us. No, the square root doesn't come with us. Only the 3x squared plus 1. So we can find what? We can find the derivative du over dx equals to what? It's going to give us 6x. So the differentiation of the function u with regard to x, that would give us 6x, correct? So once we have that, now we can draw out of it dx, which is equal to what? So dx is going to be du over 6x. All right, ladies and gentlemen, once we get all of this, we can now go back to the original problem and then substitute all of this in there. Okay, that means what? So we get here, so we take it here. So we have 6x, right, times square root of, so what is 3x squared plus 1? We said that is equal to u. So this is u then, right? So that is u. Then dx now is what? dx is du over 6x. Integral of that. Did you just see how we made this problem just looking so simple? All right. And then after that, what can we do? 6x, 6x. All right. So this then is equal to integral of square root of u du. All right. Can we now find the integral of square root of 6? Yes, of course we can do that. Okay. But to do that, the easiest way is to change the radical into a power so that we can apply the formula easily. So this is then, you have u 1 over 2, so that's the integral, then du. Okay? Then we go here. This is equal to what? So this is then equal to, so the integral of this one is u 1 over 2 plus 1 over 1 over 2 plus 1. And then we add c to it. Okay, so we add c to it because we're dealing with an infinite integral. We're good? So once we have that, so this one is equal to a u 3 over 2 because 1 over 2 plus 1 is 1.5, which is the same thing as 3 over 2 divided by 3 over 2. Now, because we have a fraction at the bottom of this fraction here, we can make an adjustment. That becomes 2 over 3 times u 3 over 2 plus c. Okay? But are we done? No, because we set up something equals to u. We said u equals to 3x squared plus 1. So we're going to have to revert back. Okay? So that would give us what? This would then be equal to 2/3. Instead of having u, is times 3x squared plus 1 power 3 over 2 plus c. Now, in some problems, you're done, you're finished, okay? But sometimes also, we have an extra line that we can go to by changing the power into radical format. So we have 2/3 then times square root of 3x squared plus 1 power 3 plus c, because the power, the 3 here, okay, as the numerator becomes your power, okay? And then the 2 as the denominator is actually your radical. Okay, so there's always an invisible 2 here. You guys remember that? Okay? So this is plus C, and ladies and gentlemen, you are quite finished. This is what it is. But remember, whenever you're having such problems, when you have a function times another one, you got to think about, do I have this format? If you have it, you got to go for it. If you don't, there might be some other ways of solving for the problem. Then it might not be this one, okay? But in this case, right here, this is what we have. You continue, you take step by step, take your time at this point, learn what we're doing, be patient, okay? And then you're going to be there. Thank you.